talked about secure communications and network segmentation, all sorts of craziness with firewalls there as well. So now let's jump in and talk about how do we actually attack these, or how do the bad guys attack them? Because, we're not going to do that unless we have approval to do so. And so when we look at it from a high level, you have to know networking and a lot about the protocols and the way that they behave in order to try to break them or try to find vulnerabilities for them. And so what we usually will do is we'll look at whatever is important for different applications that we're looking to test, like IPsec, for instance, Kerberos, or Secure Shell, and we'll go in and do our best to try to learn about the specifics, the details on how these behave, with the intent that if we're going to, maybe go in and the bad guys are going to go in and attack them, how do we make sure that we try to protect against those types of attacks? One thing is for sure that you will see on your exam is this thing that's called Kerberos. So Kerberos typically is used for single sign-on, and usually for purposes of your exam, you will always see the word tickets for Kerberos. Tickets, please, tickets. So Kerberos has a ticket granting server. It's got a ticket granting ticket, and it's used for single sign-on by granting a ticket. So instead of us, I remember when NT first came out, every 15 minutes or so, you were having to go in and re-authenticate. And then, Kerberos started to come more and more into play behind the scenes with Kerberos, or with Windows. And whenever it was adopted, it really, helped out having to continue to put in your user ID and password. And so understanding these secure communications like these, as well as some of the other ones, including but not limited to the signals that are happening with any cryptography, any RPCs, remote procedure calls. We already talked a little bit about the bottom two, SSL and TLS. And in order for us to be able to look at these secure protocols and put on a red hat or a black hat for a red team and try to actually actively exploit them, we have to understand at a high level, what happens to verify any type of user whenever we're allowing them to connect to our network. And so there's a whole bunch of different protocols that are available for us to look at. And we'll actually talk about a few of these today, but then more of them we'll talk about tomorrow. So let's jump right in and see do. So all of us use emails, and you may use this thing that's called the SMIME. If you're not familiar with that, it is the Secure Multi-Purpose Internet Mail Extensions, and that's typically used for public key cryptographic services using certificates, X509 certificates. That's the primary one that people use today for email security solutions, is either the SMIME. Sometimes you'll see the privacy enhanced mail as well. And you can go and look more about these, but really it gives us not only confidentiality, but authentication whenever we're sending emails. So let's enumerate this SMIME a little bit more and take a look at how it works. So if you have a message over here, and you have some sort of way that you're looking to encrypt it, the key will get put into the encryption process to generate the ciphertext, and then it'll also get utilized to decrypt the message in a symmetric system. Whereas in the asymmetric system, it will use the public key on one side and the private key on another side. And so these encrypted mail delivery using S-MIME extensions really comes in handy both in symmetric and asymmetric modes, allowing us to transfer mail securely. Some of the other things that you may see, the idea of whether or not these are going to be on the exam, I think is the first question. Usually of these, we sometimes see pretty good privacy, PGP, which is I believe it's an open source crypto system that you can sign, encrypt, and decrypt anything like email files and the like. Anybody ever used PGP before? Yeah, me too. It was a long time. I think I actually heard this dude, the guy that created it. What was his name? Phil Zimmerman. I heard him speak at a conference one time. Sharp dude, but he created it as a alternative to some of the techniques that were out there right now. So, how can we securely access things remotely? And by doing that, what are some of those mechanisms that we typically will use? Well, usually people will use VPN. A lot of people will use remote desktop protocol. Some people use VNC. VNC is a great tool. TeamViewer is really good. Go to my PC. These are a lot of RMM solutions, remote control and monitoring. And how do we do all that? Well, many times with any type of traditional telephones that are out there, we have the POTS, the plain old telephone system, the PSTN, which actually about 3 or 4 months ago we were out at a customer site, and they were getting into a new building, and we saw an old phone system that then no longer were in use. It was still up there. So you can either have a PBX, a private branch exchange, that comms go over a POTS. But for purposes of your exam, I would focus on VPN and RDP. At a high level, those are ways that we can actually deploy solutions for people to access our networks remotely. One of the ways is this thing called Radius, and you may be familiar with Radius. Don't get confused by the thing in the middle here, the dial-in. A lot of ISPs, as well as the big cell phone companies like Verizon, AT&T, and T-Mobile, they use Radius right now. And so that what that does is it gives you a way to authenticate based off of a SIM card in your phone to the nearest cell phone tower. So usually Radius is used anytime people are moving geographically. So you authenticate once, and then you just keep it alive as you're moving geographically. And so from like cell phone tower to cell phone tower in a large network that is 5G, or like a metropolitan area network, like in downtowns, or campus area network, a CAN on universities like Georgia Tech, for instance. You might use something like Radius. You can set that up on the wireless access points to not only help keep alive as, like, let's say you're walking from building to building, so you don't have to re-authenticate. And so Radius is kind of nice, and really comes in handy in disparate buildings. So let's talk a little bit about VPN and how does it work. It secures what's called a point-to-point transmission. And if you're looking to send data over the internet, which is the untrusted network, then you may want to consider having the virtual private network. And so typically, you'll have some sort of client that is installed on your device. So whether it's a laptop or your phone or whatever, you'll have the client that will connect out to another specific system. So it could be a client server model, it could be a client to a router, it could be a client to a server to a router. And so it's a many to one, typically, that the relationship. It gives you not only confidentiality, but integrity as well by hashing, and then allows you to create what's called a tunnel between the endpoints using different protocols. And those protocols are shown down here. And so it depends on which VPN concentrator you're using and to which that vendor actually implements as far as VPN is concerned. One that keeps coming up, though, is this IPsec. And we talked about the IPsec having the tunneling and transport mode earlier. Remember, the tunneling mode, everything is encrypted, including the authentication header and the encapsulating security payload.